Hello friends, welcome to Dr. Ossai Physiology Academy, DOPA for short. This is the place where we'll make the learning of physiology easy, exciting, and effective. Thank you for joining me. If you're new to this channel, you're especially welcome. And if you love the content that we share, kindly click the like button and also the subscribe button. And don't forget to turn on notifications so you don't get to miss any new content that we drop. Now let's get started. So today we're going to be dealing with thyroid hormone. I'm sure you know about the thyroid gland. We've mentioned it before. Secretes thyroxine and so on and so forth. But now the thyroid hormone is very special in the sense that you must know the process of the synthesis. Unlike others, you don't need to really bother yourself about that and so on and so forth. But in this one, because there are some unusual things about the synthesis, that's why you need to really know all the steps one after the other. It's simple. We're going to deal with that. And what are those unusual things? Number one is the fact that it needs a lot of iodine. Thyroid hormone, they require a lot of iodine. Okay, so that's iodine requirements. Okay, up to 1 milligram per week you need to take in iodine in your diet. If not, after some months you become iodine deficient and thyroid hormone will be unable to be synthesized. So that's one very important, why it's very special. Another special thing is the fact that usually hormones are synthesized in the cells, the particular, and we know we mentioned the cells. For example, the pituitary hormones and all of that, we mentioned somatotropes, thyrotropes, gonadotropes, and all of that. Their hormones are synthesized inside. But for thyroid hormone, the hormones are some part of it is synthesized in the cells, some part are synthesized outside the cell, intracellularly, extra. That's something unusual about it. Okay, intra and extra cellular synthetic process. That's another one. Then the third thing that is unusual about is the fact that there are two different types of thyroid hormone that can perform the function. We usually call them T4 and T3. Okay, two forms, T3, T4 forms. Okay, so these are some of the unusual. That's why we need to really study the steps in which the thyroid hormone is synthesized. Do you understand? So now let's start. Now, first of all, you know that the thyroid gland is located at this neck region, around, I think, just below the larynx, which you call the voice box. Okay, around this neck region. Now, and it's a very large endocrine gland. I think it should be among one of the largest, because the endocrine pancreas, although the pancreas is big, but the part that secretes insulin, the endocrine, is very small. So it's about the largest endocrine gland around the neck region. So it needs stimulation from the higher pituitary gland. Okay, it's one of those that. So, but first of all, the pituitary gland itself needs further stimulation from the hypothalamus. So the synthesis, first of all, TRH. That's the thyrotropin releasing hormone from the hypothalamus must first be secreted. Okay, and this thyrotropin releasing hormone now stimulates the thyrotropes in the pituitary gland. So this now stimulates TSH, which is the thyroid stimulating hormone. Okay, so that's what happens. So what is the function of this TSH? So is this TSH that now goes to stimulate the synthesis, which we are going to discuss now. So first of all, TSH is released. TSH is a peptide hormone. All pituitary hormones, they are peptide hormones. So it binds to the plasma membrane receptor in the thyroid gland. So these things here, they are representative. It's just a diagram to show you the thyroid cells. Okay, all these things, individual things there, they are thyroid cells, and because of the arrangement, we call them thyroid follicular cells, or you call them thyroid epithelial cells, or you call them thyrocytes. Okay, so let's, number one, thyroid, you need to know their name so that you don't get confused. Thyroid follicular cells, thyroid epithelial cells, or just simply thyrocytes. Okay, and then they're surrounded, you now have a cavity, which is the extracellular space we are talking about. Okay, so you have the cavity, thyroid follicular cavity here. This is the cavity. I'm going to talk about the significance of this cavity. So what happens is that it binds to the plasma membrane receptors, and then it uses the G protein coupled receptor pathway. Remember when we were talking about the mechanism of action of hormones, we talked about different enzyme linked and so on, ion channel linked, then G protein. So this TSH uses that G protein coupled receptor pathway, which uses, we talked about that, you can look at the lecture, from signal to action and so on, mechanism of hormonal action, how it uses the second messenger, CAMP, cyclic AMP, protein kinase, and so on. So the summary of everything is that it now stimulates protein synthesis in these thyrocytes. And what do? They secrete a protein called thyroglobulin. Okay, thyroglobulin. It is a glycoprotein. Okay, thyroglobulin, very important substance. Usually call it colloid. So they secrete this thing through exocytosis into this cavity. This thyroglobulin, very big. Let's use TG for short. Thyroglobulin. Okay, so they secrete, it's also colloid, very proteinaceous glycoprotein into, it's very important. So this thyroglobulin, it's a glycoprotein. The protein part is made up of amino acid, especially the essential amino acid called what? Tyrosine. Because generally thyroid hormone is a combination of tyrosine and iodine. Iodine plus tyrosine give you thyroid hormones, and we're going to talk about that. So this thing has tyrosine. So it's secreted here. So the next thing that's going to happen, we have already started the process of synthesis. Let's itemize it so it to be easy for you to understand. So number one is now the synthesis. Okay, let's put it here. Synthesis of thyroglobulin. Okay, synthesis of thyroglobulin, and then it is now through exocytosis put into this cavity. Then the next thing, because iodine is very important, iodine is gotten from the food, so which enters the capillaries, and so capillaries here supply iodine, so iodine needs to enter. That process is called iodine trapping, or rather iodide trapping, because it comes in a charged form. Okay, number two, iodide trapping. So what is this iodide trapping all about? Iodide is I with the negative charge, that it has excess of electrons. Okay, so iodide is trapped, transferred through a process. It's an active transport process through sodium It follows sodium. You know, definitely sodium is high at the extracellular part, okay? Extracellular fluid. So sodium, as sodium is going into it, iodide follows sodium and enters into this thyrocyte. But the thing is that iodide is already high in this thyroid. Thyrocytes normally have high levels of iodine or iodide, but iodide still needs to be pumped in. That's why it's secondary active transport. Okay, so through a process of secondary active transport, iodide is transferred. So that process is called iodide trapping. But now iodide will not remain as iodide. It needs to come in the form of iodine. This iodide is too reactive form. So the next stage is called the oxidation of iodide. Okay, iodide oxidation. No, in chemistry we learned about redox reduction. So oxidation is loss of electron, reduction is gain of electron. So when it loses electron, which is negatively charged, it now becomes from this to iodine. So from iodide to iodine, that's this iodide oxidation. When it's oxidized, it becomes iodine. Okay, so that's the number 3 step. It happens inside this thyroid, and the enzyme that catalyzes this oxidation is called thyroid peroxidase. TPO for short. All right, are you following? So now it has been iodized, it's now iodine. Then also this is where because it wants to go and meet tyrosine to bind with it, so it needs to now be transported from inside the thyrocyte to this follicular cavity. So that brings us to number 4 step: transport of iodine into cavity. Okay, so now, and there is something it uses, okay, before it crosses this, this, we call this basolateral membrane, the side that faces the capillary, and this side that faces inside is the apical membrane. So at this apical membrane, the channel that it uses, okay, it's called pendrin, a protein there, pendrin. Okay, so this transport into this is facilitated by that protein channel there called pendrin. So now iodine is now in the cavity. Okay, so it will now start to join with tyrosine. So there's still about 3 other processes with a special name, very important, interesting way they bind together and become thyroid hormone. We're going to learn that after this break. All right, you're welcome back. So now the next phase is the addition of iodine. Iodine is inside to the thyroglobulin, and that process, number 5, we call it 2 names: organification or iodination. The adding of iodine to tyrosine. Okay, so it's just something like this. Let's say you have let's assume this is okay, just assume that this is tyrosine. Okay, then iodine is added. If 1 molecule of iodine is added to tyrosine, it's called monoiodotyrosine. Let's write it here: monoiodotyrosine. MIT for short. Okay, that's if one molecule. Then if two molecules, let's assume another molecule is added to tyrosine, of course, what does it result in? Diiodotyrosine, DIT for short. So these are the two major ways they are added to this, either as monoiodotyrosine or diiodotyrosine. And then that brings us to the sixth step, very important. It's called the coupling step. Okay, coupling. What does this involve? It involves the addition of these two substances, monoiodotyrosine. So there are different ways it can join. You can have MIT will join with DIT to give you what? It will give you mono and di will give you triiodo. But this time it's called tyronine, not tyrosine. Okay, tyronine, which is now known as T3 because it has 3 molecules of iodine. Okay, this is the coupling reaction. Then 2 molecules of DIT can join together. Okay, so you have DIT plus DIT. That means it will now be 4. And that is not called tetra, but it's called thyroxine. Okay, thyroxine, which is now known as what? T4. So these are the 2 thyroid hormones, T3 and T4. But now they are still together with the thyroglobulin substance, the colloid, and they cannot be with the colloid when they want to be secreted into the bloodstream. So the next step is that this thyroglobulin that's now carrying these hormones that have already been formed will now have to move, okay, from this cavity into the thyrocyte. That's number 7 step. But first of all, this coupling reaction is also powered by TPO, thyroid peroxidase. Okay, it enables this coupling reaction, TPO. All right, so through process of endocytosis, okay, it's entering into the cell. So the next step is endocytosis of thyroglobulin into the thyrocyte. So what happens is that when they enter into the thyrocyte, for this hormone to be secreted, they will need to break away from the thyroglobulin so that the thyroglobulin can still go back and be reused if need be. Sometimes some new ones are secreted, some old ones can be secreted into this cavity. New ones can be synthesized. Okay, so and they are now in the thyrocyte, and then they are cleaved. So that process is known as hydrolysis of T4 and T3, and they are done by lysosomal enzyme, the lysosomes. Okay, it's the cell organ. It has all these proteases. So that leads us to the final step, number 8, hydrolysis. Hydrolysis of T4 and T3. So now they are now free to now act. But the thing is that this coupling reaction, this second part, this one, happens like 10 times faster. And that's why you have more of T4 Remember we said it at the beginning. You have more of T4 than T3. But unfortunately, the T3 is the more active, physiologically active form. So we're just going to talk about the transport, and we'll end this part 1. Then the part 2 will now talk about the metabolism, physiological actions of, and all the some disorders of thyroid and so on. So now they are now secreted. Okay, they have been broken away from this. They are secreted into the bloodstream, but they are not free. Okay, they are bound to plasma proteins, and the plasma protein, about 2 or 3 of them. One of them is known as thyroxine, number 1 plasma protein, thyroxine binding globulin. Thyroxine binding globulin, TBG. Okay, is the major plasma protein that binds these thyroid hormones. You still have thyroxine binding prealbumin, which is also known as transthyretin. Number 2, transthyretin. Okay, then the third one is albumin. Okay, so a lot, 99% of thyroid hormones, they are bound to plasma protein. So the 1% that is free is the one that is actually physiologically active, that does the work. So what is the significance of this much binding? Is the fact that you have a large store of thyroid hormone. That if you stop taking iodine in your diet, it will take some months before you become iodine deficient. Do you understand? Before you start having symptoms of deficiency of thyroid hormones, because a 99% of them, they are bound, so they'll be released little by little. Okay, so that's one of the importance of being bound so much to plasma protein. So this is what you need to know about this part 1 of thyroid hormone. Very interesting. So we're going to be learning about more of the functions of thyroid hormones. Very important. That's very, because it affects all cells. So see you in the next video.